we'll go to our next talk, which will be a technical dive into Clowder core. And this one will be from Max Burnette, Senior Software Research Engineer at NCSA.
Hello, and welcome to the technical dive into the Clowder core. You could consider this a follow-up to the Clowder overview for developers. We're going to get into a little more of the gory details of the code and how it's structured, and give some pointers into where you might look in the code for making certain kinds of edits if you want to develop Clowder, but you're not quite sure where to look for a particular type of change. We'll start with a recap of some of the code structure, and I'll be showing some code examples using IntelliJ IDE, which is our preferred editing environment you might have seen in the developer overview. I'll recap that briefly here just so you recognize where I'm getting that from. And then we'll get into the code structure, which is the major elements of the application itself and where to find certain aspects of the user interface. And then we'll get into some detail working with particular Clowder components. This includes where to find specific pieces of the code base. We're going to talk about working with resources, metadata, extractors, the search engine, streaming things for downloads, and the permissions. So again, JetBrains IntelliJ IDE is our preferred code editing environment for Scala, and thus for the Clowder Play application framework. There is a free community version, and I think many of the features that you'll see in this presentation are accessible. All you have to do is clone the Clowder repository from GitHub and then open IntelliJ and import the project into it, and you'll be able to benefit from the shortcuts and the project structure things that IntelliJ has built in. The developer overview has some specific examples, but one that I'll show in a few minutes here is to use Control-click on the use of a function, and you can jump straight to the definition of that function, which is very handy. This is the grand structure of the Clowder application, and when we look at the code base, we will see folders that match these different boxes that are shown here. So at the top you have a user that comes to the application and makes some request. We have a permissions layer that executes checks based on which user it is and what endpoint they're calling. We have API endpoints which return JSON, as well as controller endpoints which return HTML. We have a services layer which stores and retrieves data from the database. We use MongoDB by default. We have the database itself. And then we have the models layer, which is kind of the backbone for several of these other layers that defines the structure of documents in the database. So in the case of a file, we have a file model which defines all of the properties a file can have. We have services which let us fetch and retrieve file information from the database. We have a variety of API and controller endpoints that let you interact with those files. And we have views, which are template web pages that we can populate with our controllers. So we'll get into that in a little bit more detail shortly. So when we look at the code base in GitHub, we will see a folder structure that matches this diagram that we were just looking at. So on the right-hand side here at the root level, you see a folder with all of our API files, controller files, models, services, and so on. So this is kind of the first level of navigation through the code base. We'll try to step through each of these in a sensible order so that we can get a sense of how everything fits together. So each type of resource in Clowder has a model associated with it, and a model is like a JSON template for that type of resource. It's a list of properties and their data types. When we map things into the database, models are the way that we create the table definition or the document collection or whatever in order to store the data that we need. Models can be nested, so a property can have a type that's another model you've defined somewhere else. We'll see an example of that in a minute. And if you're adding new properties to an existing model that require their own named properties, like a sub-object, you might want to define a model for that. Let's look at the file model as an example. So within our models directory, we have many of them defined. These are the types of resources we'll be seeing in a moment. File is one of them, and when we look at this, we can see that file has a number of properties listed here. It has its ID, it has a file name, it has the author that created it, and a variety of other things listed here. This directly maps to the information that we store corresponding to files in the MongoDB database. Every file that we have a record of in Clowder will have an entry for all of these required properties and potentially an entry for the optional properties as well. Down here you can see an example of a nested model. A file has a license, and that type is license data. If we click on that, we can see that license data is itself a model we've defined somewhere else with its own properties. So you can use this to build fairly complex models with building blocks. And you'd find the license data model in that same models directory as well. Next are the controllers and views, which are closely associated. These are the basic front-end components for the web page that users see through the GUI. What typically happens is that controllers will receive a request, they will use services to get the data they need, and then they will pass that data to a view to populate the template and return HTML to the user. The view files look quite a bit like web pages. You'd see HTML when you look at them, but they also have functional Scala so that they can dynamically configure their components based on the data passed to them from the controller. If the views need dynamically updated data when the user interacts with them, like an autocomplete form or a lookup table or something like that, then it will use the API through its JavaScript to make those calls, and you'll see that JavaScript in the views HTML. So programmatically, when someone views a data set, we can first look at the routes file, which defines all of the different endpoints we have. This is a very important file to get familiar with. If you wanted to know where in the code we have the function defined where you call a data set, you could come here and find this endpoint. So here, the data set's endpoint that takes an ID maps to this controller's function in the data set's controller, which is defined here. So this takes a number of calls to the service to collect a bunch of information about the dataset that we're about to render. It checks permissions, it gathers associated resources like parent and child objects that are not in the document itself for that dataset, and collates all those things so that here at the end we can pass them all to our views.html.dataset web page, which we can look at here. And this is just our HTML that's going to be modified with that information that we collected, and you can see with that @ symbol where some of those variables are referenced here. That @ symbol indicates that you're seeing a snippet of Scala code. So if you wanted to modify the dataset view, you might need to modify the controller function to change what data is being fetched, and you might also need to change the view file to modify the HTML itself. So if controllers and views control the GUI, then their counterpart is the API, which is better for scripting and automated processes with Clowder. This returns JSON data instead of HTML, so computers can interpret it much more easily. We have a few different types of endpoints: get, post, and delete. You'll probably have seen these if you've worked with CRUD systems before. We support user parameters and flags depending on the endpoints, which means that users can pass arguments to affect how the endpoint is executed. And we can do a variety of things. So some of the examples here are uploading files, submitting form data to trigger extractions and that type of thing, and to do queries and get lists of resources that you can iterate over to do your alternate front ends or other types of applications. There's not perfect one-to-one functionality between the controllers and the API. There are some things that you can only do through the API, and there are some GUI features that don't have an API equivalent. API endpoints are listed in the routes file just like controllers, so we can see the corresponding endpoint for viewing a dataset through the API here. You can see that the endpoint has an API prefix on the left, and it calls an API datasets function rather than a controller's function. Now in this case, if you look at this function, it's very simple. It just returns the dataset object straight from the database cast to JSON. And this function, toJSON, is one that we have defined in the dataset model. That's shown here. And it controls how we translate the model from the database into a JSON object. So that when you call the dataset endpoint, you see an object like this. On the left is the API, where you can see a description of the dataset with some IDs. And on the right is the GUI, where you actually see a nice pretty web page. The shared piece for both of these routes is in the services layer. And this is the layer that's between the APIs and controllers and the database itself, and it's meant to be modular. The idea for Clowder has always been that we could implement different types of databases underneath the application and write service layers to interact with that type of database. MongoDB is the current reference implementation, so we have services for MongoDB already there, but there's nothing stopping a developer from adding a Postgres layer, for instance, and adding support for that. There are other components that are implemented in the services layer, such as file storage. You'll see in the code references to disk-based storage versus storing the data bytes in the database versus storing them in Amazon S3 buckets. We also have search services that can function across different search engines like MongoDB and Elasticsearch, and a message bus service, which currently uses RabbitMQ to exchange messages. So if you look at some of the service code, both of these functions we've seen so far would need to get the dataset information from the database, and that's done in the dataset services. We have a trait defined, which actually specifies for any implementation like MongoDB what has to be implemented. This is a generic trait, so our dataset service has a number of functions that should be defined. And like I mentioned, because we use MongoDB as our reference implementation, we have a MongoDB example that we can look at. In our implementation of the dataset service for MongoDB, we have a get function, which simply finds a dataset according to the ID. In another database context, this might be a SQL query. Between the models, the services, and the API and controller layers, that covers the majority of the code that many developers tend to work with in Clowder. So now that you've got a basic background on what those types of resources are, let's run through a quick tour of some of the more specific examples of working with resources, metadata, and these other things in the Clowder code. I've used this term resources a few times to refer to nebulous aspects of the Clowder application, so here I'll be a little bit more specific. Resources tend to refer to the key research components in a Clowder application, this being the project spaces, the datasets and files themselves, and any collections that they're organized into. What you see here is the basic hierarchy of data in Clowder, but a dataset is the primary unit of observation. Each of these things listed on top has a model, API and controller endpoints, and a service layer associated with them. We saw a very simple example of this with the datasets, but ideally, both the API and the controller code can share the same service calls to minimize the amount of code duplication and do their own necessary tasks with the response. If we think about changing the name of a dataset, for example, a model will define the name as a string field. We might have an API endpoint where you can put a change to the dataset title, seen here, which utilizes two functions in the dataset service. It uses get to make sure the dataset exists, and it uses update name to make that name change when it verifies that you have permission. And on the GUI, we can use that same API endpoint when you view a dataset and you click that edit button next to the name box. It'll make that put call to the API, which we'll call the dataset service, and basically leverage the same code. That means if we make some change to the dataset model that impacts this, we only have to change that underlying service call and we don't have to change it two places. Metadata has a lot of moving parts. It has formal JSON LD content. This is JSON link data. You might have heard about this earlier in the conference. And many of the features of metadata are closely tied to extractors and to search. We know that extractors can generate metadata, and we know that search operates on metadata. When you look at the code, you'll see those two things interacting. There are not a lot of rules in dealing with the metadata, which means that users have a lot of power, both good and bad. And that means that we aren't worried about things in our code in Clowder like duplicate metadata. So if somebody tries to submit the same thing twice, we will happily accept that, and it's up to the user to clean their inputs. Another thing that comes up as projects get a little older is that there are a lot of legacy extractors that are running that are important to projects which may not be updated. So changes to the Clowder GUI that require changes to extractors should be made with sensitivity to that. We also have tags, which are essentially a catch-all metadata string field. You can add any arbitrary tags to resources, datasets, and files. We do some tag aggregation that we don't do with metadata, so you can see ordered or weighted lists of the different tags that are used in the instance, and that can be informative. But pieces of the underlying code will look very similar to metadata. And again, broadly speaking, metadata and tags are for datasets and files, and those are the primary units people are concerned with in their search results. When looking at extractors, you'll notice that many extraction events are generated depending on which extractor you're looking at. These extraction events tend to be a history of activity for each extractor. Start with started, end with done. The things in between are largely determined by the author of the extractor. So you can see a lot of different things in there. You can see a lot of different lengths of code in there. And this is shown in the GUI and aggregated for reports. So this is sort of an informative way that users can get some intuition into what the extractor did and how it worked. These are also events that you'll see in the Mongo database and you can leverage for aspects of the GUI. In practice, this is also very useful in trying to troubleshoot why an extractor didn't work properly. You've probably heard that the extractor framework uses a message bus, in our case RabbitMQ, to pass messages between Clowder and extractors. So there is an extractor routing service that has some of the important logic for routing those events to the proper extractors. And if you're going to be looking at adding new events or changing how those events work, that's the first place to look. Extractors, for their part, use their extractor info file to tell Clowder what types of events they want to listen for, and then Clowder is the other party responsible for sending them the events that are relevant. When it comes to searching through metadata, I'm going to talk a little bit about how we have our Elasticsearch configured. There are a few different ways to search in Clowder. You can search through the API, or you can search the GUI search box that's in the top right corner of the web page, and those are equivalent. They use the same code in the back end, and you can use the same syntax that we'll see in a moment for those. There's also an advanced search interface that's currently metadata focused. So within Elasticsearch, we index a lot of information about each resource, things like the name, the description, author, and metadata. But the advanced search, which is the closest thing we have to a faceted search interface, we currently let you autocomplete through metadata, but not through the other fields. Elasticsearch syntax is a little bit complicated, so we actually have our own simplified search syntax that wraps on top of this to make it a little bit more user-friendly. The Elasticsearch plugin contains the majority of the interesting code relating to the search engine, and I'll just point out a few places to look if you're interested in this. Get Elasticsearch object mappings is where we actually define our schema with rules that we have for the Clowder search interface. And we don't predetermine many of these things, but we do have some, like the created field being a date, because the type in Elasticsearch impacts how you can search through things. Metadata field types are determined automatically when the metadata is submitted for the first time. When Clowder gets a new piece of metadata that it hasn't seen before, or a new field it hasn't seen before, Elasticsearch will do its best to try and guess at what the data type is. This is important because date and numeric fields handle greater than less than operators differently, and you might get surprising search results if your field that you thought was a date is actually being treated as a string. You'll notice in those mappings that we only define one type of object that's stored in Elasticsearch, and we actually convert all of our resources into that object when we index them. This occurs in our search utils get Elasticsearch object functions. There's different flavors for different types of resources, but they take a larger Clowder object from the model and trim it down to an Elasticsearch object so that everything is consistent across the type of data it's stored. The main thing this allows is searching cross resources more easily. To actually build the queries, we have a fairly complex set of code that converts the user search query into an Elasticsearch-friendly query object. So if you provide a string, you have one function that parses the string, and if you use the advanced search interface, then that provides JSON that needs to be parsed by the service. Check result permissions is our way of filtering out the results the user is not allowed to see. This is interesting because Elasticsearch does not index permissions. It's too complex. So when you do a search, most likely you will get back resources in that search that you don't have permission to see, so we have to filter those things out. We have an accumulate page result function that gets more results as needed until the page length is reached. So if you request a page size of 10 and you get 10 things but 5 of them you don't have permission to see, it'll keep fetching more until you fill up that first page of 10. When it comes to downloading things, Clowder is fairly flexible in that you can download individual files, you can download data sets which are collected into a zip archive automatically, and you can also select arbitrary sets of files and data sets and download those as new packages. So Clowder has a fairly robust set of utility methods for streaming files and data sets into zip files along with their metadata. We use these for downloading things in different forms. And within the code, Clowder uses enumerators to stream bytes. This keeps the connection open for long downloads so that the user's computer doesn't close the connection while they're downloading big files. And it can also generate bagged information too, which are XML metadata about the thing you downloaded. The key takeaway is that if you're writing code that involves downloading information from Clowder, take a look at the datasets enumerator from dataset function to see an example of recursive streaming of dataset and file contents in order to create a zip file that has this nice hierarchy within it. Every request that comes into Clowder will have some user associated with it, even if that user is an anonymous user, so we can execute permissions on that user. Every endpoint can have permission settings, and good permissions can save unnecessary work later. So if you check up front whether or not a user has permission to view some resource, you don't need to check repeatedly later whether they can download the resource, whether they can modify the resource, and so on. API permissions also has both check permission and check permissions, plural, which means that you can provide a list of resources and a permission and check a bunch of things at once. You get back a nice object with a list of approved and denied resources. These are all tools that you should be aware of to avoid checking permissions more than you need to. And that's pretty much it. Here's a recap diagram of what we started with. We've seen examples of files in the API, the controllers, the views, services, and models. And we've seen specific examples of how some of those services can be integrated or changed. Thank you.